First thing, before you start answering these questions on proofs, you need to know your properties of your palms. Okay? I send you a document with the properties of the quadrilaterals. You need to familiarize yourself with the properties, especially the one for the palm. Right? Then number two, so far I've done, I think, one example. Okay? The way that I did that example, that's what I expect you to do here. Don't write your own reasons. Okay? Also, I gave you a copy of the acceptable reasons in the FET phase. Forget about grade 8 and 9. The acceptable reason that I gave you, you have to familiarize yourself with those reasons. Okay? Under quadrilaterals, we also have converses of the properties. When you are proving that a quad is a palm, you use the converses of a palm. Okay? And the converses start with the word if. Okay? The converses, if you go to the acceptable reasons under quadrilaterals, okay, if the reason starts with if, then that's the converse of the original theorem, and that theorem is based on the properties of the quad. In your maths book, right now, if I come to you and ask you to open and show me your acceptable reason, they must be in your maths work, not in any other special file. Okay? All right, so let's do this question. All right, so in this question, we are told that PQRS is a palm. So let's label the shape PQRS. So that's P, Q, R, and S. Okay, that's our palm. We are told that it is a palm, which means all the properties like the opposite sides are equal and parallel, the opposite angles are equal, the diagonals bisect, and so on. You can apply them there, okay, in that quad. Then PR and QS, they intersect at T, so the diagonals intersect at point T. Okay? The diagonals intersect at point T. Right, let me just remove those diagonals to make it clear. Then QT is equal to RM. So I'm going to indicate here that QT, this length here, is equal to RM. Those two are equal. QT is equal to RM, that's given there. And SM, okay? SM is equal to PT. Okay? Now, the question says, prove that RTSM is a palm. RTSM. Now, your RTSM is this shape here. So we have got R here, and then we have got T there, we've got S, and then we have got M. So that's the shape. This is RTSM. Okay? Now, when you want to prove that a quad is a palm, sometimes you may need to use congruency. Okay? Whereby you have to identify two triangles first, you prove that they are congruent, and then from there you carry on. So here, my strategy before I carry on, I just want you to be aware of the following. Since we are told that QT is equal to RM, QT, this length here, is equal to RM. It therefore means that ST is equal to RM, because the diagonals what? Bisect. Okay? So the first thing that I'm going to write is to say QT is equal to RM, and this is given. Okay? Then I'll say ST is equal to QT, and the reason is the diags of a palm. We know that they bisect. Okay? This is based on the acceptable reasons. This is how the reasons are written on the document I gave you. Okay? Just write diags of a palm in that using this notation. I want you to get used to this notation. I know that in the past you were not told about this. But now we are in the FET phase. Adapt to the new way of doing things. Okay, so what I'm saying here is that ST is equal to QT because we are told that PQRS is a palm, therefore the diagonals PR and QS bisect each other. Hence, QT will be equal to ST. Okay, you have to know your properties of a palm. If you don't know your properties, then you are going to find this type of questions very challenging. Now, because I now have these two statements, both of them have got QT there. It means I can come up with a conclusion and say, therefore, ST is equal to RM. Okay? That's a conclusion or a deduction that I'm making based on these two statements. Okay? So now I have proved that RM is equal to ST. Okay? The next thing now is to prove that RT is equal to MS. That's the next stage. Okay? So I'm going to say SM is equal to PT, and this is given. Right? And then from there I'll say RT is equal to S is equal to PT. Okay? It will be RT is equal to PT, and the reason is because the diagonals of a palm bisect. Okay? Again, from here, you can see that PT appears in both statements. So we have PT here, we have got PT there, therefore, I can say, therefore, RT is equal to SM. Okay? Now that I have proved, I'm sure you can see that the opposite side of that quad, that is RTSM, are equal based on what I have done here. I have proved that both pairs of opposite sides of the quad are equal. It therefore means I can say the quad is a palm. My reason would be converse opposite sides of a palm. Okay? Converse opposite sides of a palm. Right? So I'm going to make a conclusion now. Right? The conclusion, then I'll say, therefore, RTSM is a palm. My reason, converse opposite sides of a palm. Okay, this is what I expect from all of you. Okay, this is what I expect from all of you. I proved that both pairs of opposite sides are equal. Because of that, I know that for a palm, the opposite sides are equal. Therefore, in this case, I can say it is a palm. Okay? All right? Any question? All right. Now, I just want you to be aware that when you're answering geometry questions like this one here, part A, or the first part of the question, has a relationship with the second part. So 3A has a relationship with 3B. Okay? So I'm going to move on to the next page. All right? The next page now, I now know that RTSM is a palm, so I'm going to indicate it. It means my RQ is parallel to SP. Obviously, QP is also parallel to RS. Furthermore, since I have proved that RTSM is a palm, it means that that length, the ST, or I'll call it SQ, is parallel to MR. Furthermore, I want you to be aware that the line NQ, okay, which is an extension of RQ, is also parallel to SP. I hope you are aware of that and you can see that. Okay? So NQ is parallel to SP. What that means is we have a trapezium here. Okay? The trapezium is going to be, okay, let me call it PQNS. It's a trapezium. Okay? Because a pair of opposite sides are what? Parallel. That's a trapezium. Okay? If you want, I can write that down. Okay? Now, what's the objective? The objective is to prove that QR is equal to RN. QR, okay? QR, this is the length here. That is QR is equal to Rn, which means I want to prove that those two are equal. That's the objective. Okay? Now, in my case, for me to do the proof, right, I'm going to use congruency. Because for this question, congruency will be the best. So I'll identify two triangles and prove that those two triangles are congruent. Okay? So that's how I would approach it. I don't know how you might have done it. Probably you might have seen another way that I'm not seeing, which is very much possible for this question. So, okay, before I carry on, let me remove those two because they are not equal yet. Right, so the first thing, I'm going to identify my two triangles, and my two triangles are going to be, right, I'm going to use NRS. If I prove that NRS is congruent to RQP, then I can say, therefore, RQ is equal to NR. So I'm going to use congruence. Right, the good thing is I've got some lines that are parallel. Like, for example, because SP is parallel to NQ, it means this angle here is going to be equal to that angle. All right? And be aware that SP is equal to RQ. Okay? So I think the triangles that I'm going to use are going to be NRS, and I'll also use PRS. I'm going to prove that those two are congruent. That's the route that I've decided to take now. So this angle is going to be equal to that angle. They have a common side, which is RS. I hope you can see that. Furthermore, if I can prove that this angle here, so I've got this angle, then the other one that I might need to prove that it is equal may be, okay, this angle here. Let's see. I have, okay, this angle here. Okay, it's not equal to that, but this angle is equal to that angle. I may need to prove that, why those two are equal. All right. Okay, this angle here is equal to that. Well, do you agree with me that this angle here is equal to this angle? They correspond. Okay? Am I right?
Yes.
Because if this line is parallel to that one, and this is a transversal, it means that angle is going to be equal to that. Okay? So, and it is also possible that this angle, in fact, it's not possible, but it is a fact anyway, that this angle here is equal to that angle. Am I right? Yeah, because if you look at it, MR is parallel to ST. Therefore, this angle here is going to be equal to that angle. They are going to be alternate angles. Okay? Now, so if I can prove, so if this angle here is equal to that one, then I'm done. Okay? I'm not going to stress about angle N being equal to angle P and therefore being equal to angle QRP. So I'm just going to use congruence based on double AS or S double A. So I'm going to prove my congruence based on this. Okay, I don't know how you approach it, but this is how I'm going to. Do you have a question? Okay, so I'm going to say in triangle, right, the way that I'm going to name it, I'm going to use the letters of the alphabet. So I'll start with N first. Okay, which one starts first? A, S, and R. So it will be NRS and triangle PRS. Okay, please, I want you to be aware that the way that I'm going to prove that QR is equal to RN may not be the only way. I'm doing it based on what I'm seeing. Okay, you might have seen something else. As long as it's correct, it will be fine. So, number one, I'm going to say RS is common. Okay, I hope you agree with me on that. RS is a common what? Is a common side. Then number two, I'm going to say angle NRS will be equal to angle RSP. Okay? Those two are equal because of alternate angles. Right? Then when you take the lines that are parallel, there are many ways of writing them. First, I'll start with SP being parallel to. Now it's your choice. You can write NR or you can write NQ. It's still the same. Okay? So I'm going to write NR. But if you put NQ, it will also be correct. Because NQ is a straight line and point R is along NQ. Then number three is going to be, I'm going to say angle, well, the angle that I'm going to, is this one here being equal to that. So I'll call it NSR. NSR is equal to PRS. PRS. Right? Again, it's because of alternate angles. Okay? Then, your lines that are parallel, if SR is the transversal, it means it's going to be MS is parallel to RT. You can also write this NS is parallel to RP. So it's your choice. So I'm going to write MS is parallel to RT. Okay. Now, I just want to emphasize that, as I said earlier, the answer in part A is very important because you need that to do part B. Okay. Then from here, I can now safely say, therefore, triangle NRS is congruent to triangle PRS. And my reason will be double AS. Okay. Now, from here I can say, therefore, NR is equal to SP. Okay? But that's not what I want. Okay? The good thing is, I know that PQRS is a palm. Therefore, the opposite sides are what? Are equal. So, my next statement is to say, SP is equal to RQ. And the reason here will be opposite sides of a palm. Okay? Therefore, I'm sure you can see here that we have SP here, we also have SP there. I hope you can see that. The SP is appearing in both statements. Therefore, we can say, therefore, QR is equal to RN. Okay? QR is equal to RN. Alright? Alright. Is there anybody who did it in a different way? Maybe you can share with us.